Hey guys, tonight we're going to be talking about rational functions, and what we're going to do is we'll just go through some stuff. Now, the first thing is the definition of a rational function, and you've done these last year. These are a rational function is just a fraction with polynomials. Now you can look it up and then make it more complicated, and then instead of a fraction, they'll say quotient, or however you want. It's like an example of say something like f of x, the function, and we can say something like maybe an easy one upstairs, x plus 1, and downstairs we can do something like x squared minus 4, and it's just two polynomials and inside a fraction. Now, based on this equation, we can graph this thing without a calculator, and there's certain things that we're going to look for. So the things that we're going to look for will be vertical asymptotes. Let's try to save that. Asymptotes. And I just call these usually VA. And we're going to be able to find holes. And in class we were calling holes what we call them, removable discontinuity, point discontinuities. Those are holes. We'll be able to find the zeros, and more commonly we just call them roots. Right? That's where the function, the y equals 0. What else are we going to find? We're going to find horizontal asymptotes. And we're going to find slant asymptotes. Not in this video. We'll do this in class. It's easy, but we'll talk about it this week. And the last thing we'll be able to find is y-intercepts. Or I should say y-intercept. There's only one of them. Get rid of that. All right, now let's talk about where we'd find these things. Now, vertical asymptotes, you find this in the denominator. That's where you'll find vertical asymptotes. Slant, we'll talk about the roots. Roots are in the numerator. Okay, and let's slant. We'll do this one later. All right, so not now. Let's see now. Holes. Holes are this. When you factor a problem, holes are what cancel out. Okay, so when we do a problem, something cancels. That's how you know there's a hole. All right, in the horizontal asymptote, there's 3 cases. We'll talk about that. There's 3 cases we got to worry about. And finally, the y-intercept. Oh, this is a good one. The y-intercept is the ratio of the regular numbers in the back, or the ratio of constants. Constants in back. Okay, we'll talk about that when we come up to it. So let's look at some problems. All right, we're going to look at the equation for this first one. F of x equals x squared minus 2x over x minus 2. It's a fraction with polynomials. That's a rational function. Now, what we're going to do is I'm going to type it in the calculator just so you can see that this works, and it's not just like, it's not magic here. All right, so I typed it in. Just be careful, and notice I put parentheses around the numerator and parentheses around the denominator, and just be careful. And we graph it, and it said this: find the hole. And when you look at this picture, you don't see a hole. Well, you know what? I gotta fix my window, and this is where we do negative 9.4 to positive 9.4. And what that will show us is, at that stage, you'll be able to see there's like a bump. There's a missing part in the graph, and that's where the hole is. Well, let's do this. Now, we said before to find the holes, or the roots, or all the stuff. What you want to do is you want to factor first. You want to factor. Okay, so I want to break this thing down. All right, so I'll look at the top one. I get an x minus 2. It's the greatest common factor. And downstairs is x minus 2. Now, holes are from when things cancel out. So we see how this cancels out? Okay. So for the whole, if it cancels, wholes cancel. So what we do is we take the x value. So I know x equals 2 would be, it makes this undefined, right? But it'd be, 0 over 0. So that's going to be the whole. Now what we need to do is get the y value by plugging in to what's left. And you're probably like, plugging into what? Well, up in here, I still have this x, okay? That's left. So I'm going to plug this number 2 into the spot. So the only thing is going to be 2. So the y value, the f of x value, right, when everything was canceled out, will equal 2. So the whole is 2, 2. Let's take a look at that. Let's check that out, right? If we went to our table on this problem, notice the error occurs at 2. That's where it's undefined. But look at the points. It goes 0, 0, 1, 1, 2, error, 3, 3, 4, 4, 5, 5, 6, 6. It wants to be a 2. So that's the whole. All right. Now let's see what else we can get. It says find the root. The root's in the numerator. So what we do is we set the numerator equal to 0, right? So now this is like, don't even look at this 2 anymore. You set this to 0. 0 is the root. You set whatever's left upstairs, right? You find the roots for the numerator. And since the 2 cancel, it can't be that. It could have been, originally, it could have been 0 or 2. But the 2 is a whole, so it's not a root. So therefore, it's just x is 0. And that's from the graph. We saw that also. That's where it crosses the x-axis. Let's try another one. Find the vertical asymptote. All right. The vertical asymptote. Here we go. Let's take a look at this thing. The vertical asymptote is in the denominator, so I look down here. Well, what would make this undefined? Well, x equals 4. That's the vertical asymptote. And the vertical asymptote is always an equation. So if I sketch this thing, okay, so 1, 2, 3, 4, very similar to the problems we've been seeing lately. And what we do is we'll see that it crosses. You know what? They didn't ask us, but I can find the y value, the y-intercept. The y-intercept is the back numbers, right? So see how it's a 1 and a 4? Well, 1 and negative 4. So it's a negative quarter. So here, at negative 1/4, I know that's a y-intercept. So this graph goes like this. And it goes something like this. All right, so once again, wholes cancel out, vertical asymptotes are in the denominator. The roots are in the numerator. Y-intercept is the ratio of the back numbers. Let's try another one. All right, horizontal asymptote. 3 cases. All right, 3 things I got to worry about. All right, let's look at the first one there. Ready? If the numerator has a higher degree, there's no horizontal asymptote. No horizontal asymptote. We already looked at that picture. That picture was the line, right? That picture was, it was this line before, right? We had a 0 here. That's this picture. Well, there's no horizontal asymptote because the degree here is 2. 2 is bigger. All right, let's look at the second one. If the degree in denominator is a higher degree, then, all right, now hold on. Now we just did this picture, right? It crossed here at 4, went like this. And this one crossed here, negative 1/4 was the y-intercept, and it went like this. Okay, and that was the second problem we did. Notice the x-axis is the horizontal. So the horizontal is the x-axis. Now, that's not an equation. That's just telling you what it is. That's y equals 0 is the x-axis. And then we get this third case. Notice they're both squares, right? The problem, polynomials. So if we have the same degree, okay, all you do is you take the ratio, ratio of lead coefficients. Now, so downstairs is a 1. So this would be y equals, correct, because I want a horizontal line, 3 over 1. Those are the front numbers, 3 over 1, which is 3. That would be the horizontal asymptote. All right, now I know the video is getting long already, but let's try one problem, and let's just go through all the parts and see what they are, all right? All right, so let's take a look at this problem. So it says, find the following and sketch the rational function. And we have to find the vertical, the holes, the roots, the horizontal, the slant, and the y-intercept. Now, I already told you the slant is not today. Okay, we'll do that this week. So I'm telling you, this doesn't have a slant. We don't have to worry about that one. All right, now the other ones, I need to factor. Oh, wait, I don't have to factor all. Remember, take a look at the powers. This is x squared, the bottom is x squared. I can do the horizontal right away. So the horizontal is the ratio of the lead coefficients, 3 over 1, y equals 3. And also, I can look at the original to do the y-intercept. What I do is I look at the back, the regular numbers, the 3 and the negative 1. Well, the y-intercept, 3 divided by negative 1, I know for a fact it crosses at negative 3. All right, now to find the other parts, I do need to break this down. So I'm gonna factor this thing. So let's take a look here. Now, so first off, you take out a 3, and I get x squared plus 2x plus 1. So this really wants to be 3 parentheses x plus 1, x plus 1 over x plus 1, x minus 1. All right, we have verticals, holes, roots, left. All right, so if it cancels out, it's a hole. So the x plus 1's cancel. So the hole has to be at negative 1, because that would be what makes it go away. And then what I do is I take negative 1. I plug it into what's left. So this would be 3 times negative 1 plus 1 over negative 1 minus 1. The numerator is 0, so the whole thing is at 0. The hole's at negative 1, 0. The vertical asymptote is the downstairs. So it says x minus 1. The vertical wants to be x equals 1. And finally, the root is whatever's left. And we look, and it would be negative 1, right? So you might be thinking, oh, negative 1. But hold on. Negative 1 was a hole. Well, guess what? You can't be a root and a hole at the same time. So roots doesn't have any. There are none. It just doesn't work. So I can look at this picture and I can actually make a graph from it. So I'm saying down 3, I bet across. At negative 1, 0, it's a hole. At positive 1, it's a vertical asymptote. So something like this. At positive 3, it's a horizontal asymptote. And now look, if the graph is going to go right there, right? So this is what, right? Now I'm not expecting you to do this, be able to do this at this moment. So this wants to go like this. So what's going to happen is it's going to go up and kind of curve around. It's a sketch. It's a sketch. It's not going to be perfect. And this wants to kind of go, make it nicer than that. Oh, that's banged up. But that's okay. And I would call this f of x, x-axis, y-axis. All right. And what's going to happen is by the end of next week, you'll be able to do this without a problem. And let's just plug it in the calculator, and let's just see what it looks like. And that's the That's not too shabby for, just without graph paper or anything, just, looking at an equation. All right, so if you had trouble, we're going to be working with this for the next couple of days. It's going to take like 3 days to do this. So you'll get to this point of, this fluency. I'm not expecting you to be able to bang this problem out by yourself right now, just after a little while. All right, have a nice night.